third grade, Unit 1, Lesson 1. This is the unit Multiplication Division Area Part 1, and the focus today is on equal groups as multiplication, rather than focusing on amount in each group or inversion of totals. This lesson is for Tuesday 8/20, first full day of school. Standard is 3.08.1, which it's important to understand the connection between the standard and AIM, so I'm going to sit there for a second. This is interpreting the product of whole numbers. For example, interpreting 5 times 7, 5 as the groups and 7 as the amount in each group. Focusing here, the word total and product is interchangeable. We want to make sure that both words are used today. The aim from Achievement First is mathematicians will be able to represent equal groups, situations with multiplication equations and models by thinking of the number of groups, the amount in each group, and the total. Again, those two words, product and total, being interchangeable. So what we want kids to understand today is I have a group, in that group is the same. I have a series of groups, I might have 3 groups, and in each group is the same amount. And when I count up all of what is inside of each group, I'm able to get the product or the total. Please spend some time sitting in this narrative each time, because it does speak to what kids need to get better at, what's hard about that, and where we're going to focus and funnel our time. This will help you guide your today, tomorrow, and everyday statement, the TTED statement. What key points, how key points, biggest thing for me is the word factor here. It has been mentioned previously, and so I want to make sure that as I'm working with these problems, I'm thinking about factors as well. So this 5 times 7 is not just groups and amount in each group, but it's factor and a factor. 2 factors multiplied together gives me a product, which is the crux of multiplication. What I do want to point out to you, and because our focus this school year is ideas over procedure, this right here can very quickly proceduralize a scholar's understanding of multiplication. It says that the first factor is always the groups, the second factor is always the amount in each group, but it doesn't speak to what it actually is. When I know that, and my fear is that a kid would see an equation like this, they would go, that's a group, that's amount in each group, and my total is when I count all. Whereas this is actually 5, it is groups, but being able to visualize and understand that it's 5 groups, I drew this right up above, and there's 7 in each group, 1, 2, 3, 4, 5, 6, 7, or you can do what I did up here when I was being a little bit lazier, and then counting all to find that product or that total, whatever you want to start with. They're going to use total and product interchangeably, and scholars need access to both. Great. This section is important to me. It kind of gives me an idea of where the network is versus where we are, and what I want to draw your attention to is there are no annotations and no sense making happening here apart from these quick labels that do make ideas over procedure real, but I also think that there's more to be done just to give kids access to word problems. By the end of today, we need kids to understand what a factor is, what multiplication is, and what a product is. And in the work outcomes from today, we need to see a visual model. This is missing labels. We need to see repeated addition, again, missing labels. And we need to see an equation driven by the idea of 10 groups of 2. There's a problem later on that talks about 10 students and hands. And this 10 groups of 2 leads to 10 factor, 2 factor, 10 groups, 2 amount in each group, giving you the product. And scholars should be able to say, today, tomorrow, and every day, multiplication represents equal groups situations. This is actually a very strong TTED statement. All right. I did the first problem. I'm actually going to model the second problem. I know I always start with my big question. Baba is a baker. He wants to know how many eggs he has so he can start baking cakes. He has 4 cartons of eggs. Each carton has 5 eggs. Wants to know how many eggs in all. Total eggs is my big question. My first task is to, I actually think for me today, because of where I'm at mathematically as a 3rd grader, I want to represent the 4 cartons with 5 eggs per carton. And then task 2 is to get to my big problem, find total eggs. This is why you should work in pencil and not pen. Representations, my annotations. All right, I'm gonna start representing with a visual model first. This is the pictorial part of that continuum. I know I have 4 cartons or 4 groups. 1, 2, 3, 4. I'm gonna label this 4 cartons, and I'll put a G for groups right there. In each carton is 5 eggs. Five eggs in each group, and I don't know the total. The next way I need to represent, I'll label that 1 just because it's helping me. It doesn't have to be that way. I need to use repeated addition, and my repeated addition is driven by this model right here. If I go back into the questioning sequence, this part of the problem, or this part of the intro to new material comes, on the next page. Bob is a baker. How does the multiplication equation match the story? Why did you write 4 times 5 and not 5 times 4? They don't push the repeated addition there, but they do here, and this is more of a reveal. This is repeated addition because you have how much in each group and how many times. So if we're still struggling at this point in time with getting kids to state that, I might say, if need be, how much is in each group and how many times do we see that, which actually builds multiplication understanding. I see 5 plus 5 plus 5 plus 5, which is literally 4 groups of 5 to get, we're gonna call it P for product or T for total eggs. And then finally, third step, I know from this problem I had 4 groups of 5 eggs, and that leads me, with very limited space, to 4 times 5 equals, I'll do T, I'll go back and change that to T for right now because I don't want to switch them, and this is 4 groups of 5 in each group, giving me my total, which is unknown. So that's the representation. There are 3 different ones. As we move in to the rest, kids actually need to have access to repeated addition, not just for the workshop model, but there are places throughout the lesson that require kids to match 2 equation that represents this visual model. And so I want to make sure that every single time a kid is asked a problem, we are attending to what they're going to need to do later on. I'm now going to move into the solve. 4 times 5 equals what? I would go back and count all. I would go back and add up, or if I just know that fact, I would know the answer is 20, and then my complete sentence answer. There are 20 eggs in all for Baba the baker. Again, just doing these first 2 problems doesn't let me see what's coming up later. In this, the consolidate the learning part, the question, like there's a misunderstanding around this being a group of 3, and if this is actually 3 groups of 4, it's not, because again, the key takeaway is multiplication. Multiplication represents equal group situations. This is not an equal group situation. I would go through, select the problems that are most impactful, and then quick heads up here, there's not a lot of space for scholar work. Big problem tasks. I do think the big problem and tasks are stronger than knowns and unknowns, plus all of the crazy annotations that come out of it. We can play around with that this year.